Okay, 9, 7 probabilities. So we're going to put things together from what we've been doing, the ways we can count things in order to find the probability. The counting is still going to be an issue. The permutation, combination type stuff will be. An experiment is anything for which the results are uncertain. So it can be anything. An experiment, when you hear the word experiment, you're thinking like a science experiment, correct? Okay, but an experiment can be like how many people, I'm going to count for 3 weeks, how many people are here by 7:45 in my room, how many people show up at, what time you guys all show up. That's an experiment because I don't know for sure when you're going to show up. Like today, I thought I was only going to have 3 people because you 2 are normally here earlier and you were here late. So
I've been taking my time.
I see that. Okay, outcome is what happens during that experiment. So my experiment is recording what time you arrive in my classroom. The outcome is what time you actually did arrive. The sample space is the set of all possible outcomes. So anywhere from between 7:45 and 8:10, if I do 5 minutes or 1 minute, that's the sample space. An event is a sub-collection of a sample space. So my sample space is from 7:50 to 8:10, but the event is the actual time you show up. Does that all make sense how I broke that down? Not really. Okay. You're not going to have to identify events, outcome, sample space. You're not going to have to tell me those, but you do need to know what are all possible outcomes. And your counting principles that we've done all week lead to that. Help you figure that out.
Mrs. Baumgartner's home today, isn't she? Just Blaine is sick.
I was going to say, it has to be one of the boys. She has to be at the game tonight. Bladen, are you good?
Mm-hmm.
Okay, find the sample space for each of the following. 1 coin is tossed. What's the sample space? What can I get?
1 outcome.
Like what?
Heads or tails?
Heads or tails. So I can get heads or tails. 2 coins are tossed. What could I get?
Heads.
I could get heads, heads,
Heads, tails.
heads, tails,
Tails,
heads, and tails, tails. 3 coins are tossed.
Heads,
Heads, heads, heads.
tails.
Heads, tails.
Heads.
What?
Heads, tails, heads. Heads, tails, tails. Tails, heads, tails. Tails, tails, heads. Tails, heads, tails.
Say that again?
Tails, tails, tails.
I think we're missing something.
Tails, tails, head. Head. Yeah, number.
Yeah.
So, when you do these, you have to do them in some kind of an order so you can keep your pattern, right? So heads, 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 tails, and then we're going to move the tails forward. Did we do a tails, head, head? Nope. And 8 is all there is, so. Okay, and I know there's 8 because how many events can happen when I flip the coin once? How many things can happen? 2. Then I flip it again, how many things can happen?
2.
And I do it again, how many things can happen? 2. So there is 8. Okay. So probability of an event, I wouldn't write all of this. Okay, when we write something, we write P of, and then a word, usually. So probability, and then we'll put heads in there. So that means probability of getting a what? Head. Or probability of hearts. So that's probability of drawing a heart. So you should be putting P of something, okay? Now, on the top is the number, that's what the N stands for, of favorable events, what you want, the number of things you're looking for. And the bottom is N of S because it's the number in the sample space. That's why it's called N of S. So it's what you want over the total number. Just like it's a percentage, right? It comes out as a decimal, which is a percent. How do you find a percent on a test? The number right, which is favorable events, out of the total number there is. Do you know how to find probability that way? I would think so. I would think you've done that in the past. Just basic. Am I good? Okay, the probability of event must be a number between 0 and 1. 0 is an event will never occur. It cannot. It's called impossible. And 1 is an event is certain. Okay, you cannot have a 110% chance of happening. People say it all the time, right? They say things like that. It is not possible to have an event be larger than 1. 1 is 100%. 0 is 0%. So if it's 90%, it's 0.9. It's not above 1, is it? So, are there very many things that are completely impossible or certain? No. There are very, very, very few things that you could say have a 0 chance of happening. There are very few things that you say that there is 100% chance of happening. I know that I will die someday. That is 100% going to happen, right?
Not me.
I know. They're going to freeze you and keep you alive forever. But you're dead when you're froze. So, there are very few things that happen to us in our lives that are 100% going to happen or 100% not going to happen. Have you ever heard nothing is certain in life but death and taxes?
Yeah.
Okay. It's pretty much that.
There's 100% chance I'm going to marry Matt.
Is there?
No.
Matt just said no, so that's not 100% chance.
That's what he thinks.
Oh, okay.
That's what I know.
Were you guys done with the other one?
Yeah.
Okay. 2 coins are tossed. What is the probability that both land heads up? Okay, so let's talk about the 1 coin first. Okay, well, we had I'll just write it out. We had our 2 coins earlier in your sheet, right? You got heads, 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 tails, tails, heads, tails, tails.
25% chance.
Okay, so P of heads. Well, we need both heads, right? So there's 1 out of 4. So the probability is 1/4. I think you guys probably could have done this without me telling you, right? A card is drawn from a standard deck of playing cards. What is the probability that it is an ace? So P of ace. How many aces are in a deck? 4. How many cards are in a deck? 52. So 1/13. You also could have done it just, well, there's 1 in each suit, right? So just 1/13.
So on the homework, do you want us to put 1/13 or?
Well, your final answer is 1/13. I mean, you can put 1/52nd, but your final answer should be 1/13.
Bring cards on Monday and have Matt play 52 card pickup.
We should bring like 6 decks and make Matt pick them all up.
I have 2 decks.
That would be 312 card pickup.
And organize the cards in the right decks.
Oh, that'd be fun. Just to watch and laugh at them.
You act like I do it.
I know you would do it. Okay, 2 6-sided dice are tossed. What is the probability that the total number of 2 dice is 7? Okay, so how many ways can I get 7? 1 and 6,
4 and 3.
3 and 4, 4 and 3, 2 and 5, 5 and 2. What about
6
6
and
and 1? Any more?
No.
So 2, 4, 6 ways. So we're going to do the probability sum of 7. Ooh, that's a 2. And I did it again.
Very improbable that you're gonna get it.
Okay. There is 6 ways, but how many possible combinations are there? When you throw 1 dice, how many possible outcomes are there?
Time.
How many possible outcomes when you throw a dice? A 6-sided die?
6.
6. And then we throw another 6-sided die?
Would be 36.
It would be 36. But when I reduce it, it'd be 1/6. In Arizona's the pick game, a player chooses 6 different numbers from 1 to 44. If these 6 numbers match the 6 numbers drawn in any order, the player wins the top prize. What is the probability of winning the top prize if you buy a ticket? Because if you don't buy a ticket, what's your probability of winning?
0.
0. That's not possible. Actually, it is. Somebody could hand you a ticket, correct? Okay, so we need 6 numbers, 1 through 44. So a probability of a win. I'll take a win on a lottery. How about you guys? Yep, you're going to win. Okay, so 1 through 44, and I'm picking 6 numbers. So I go 1, 2, 3, 4, 5, 6. How many choices do I have for my first one?
44.
44,
43.
43,
40, 39.
and if 0 is included, it would be 45, right? Don't forget to add in 0. Okay, well, but how many possible numbers are there? No.
Is it during 0 through 9? That'd be 10 numbers.
Well, no. Because you're picking 6 numbers, right? It would just be 6 factorial. So can we reduce any of them?
Yeah.
We can get rid of 40, can't we? Well, 6 if 6 goes into 42 7 times, and 3 goes into 39 13 times. Wait. I'm not finding the probability right now. Okay, so in order to get the probability, we have to have the numbers, right? And I wanted to do it this way, I'm sorry. 44, choose what? How many are we choosing? 6. Okay, what I was doing was this, but when we did the 44, 43, 42, that was with order mattering. Does order matter? No. My order, it does not matter, does it? Okay, so we got to use that. Okay. What? Yeah, I was trying to find. I put that in the wrong place. Okay, so there are 44, choose 6 winning numbers, and winning numbers do not go in the bottom. They go in the what? I mean, not in the top, they go in the bottom. Okay, there's 44, choose 6 winning numbers. But how many ways can I win? 1. Isn't there only one way to win?
Yeah.
To get those 6 numbers? Yeah, I was putting them in the wrong spot. Sorry. So we need to do our formula, or we can use our calculator to do that, can't we? You guys are going to set it in the formula, but then we're going to put it in our calculator. So what's the formula for 44, choose 6?
44 factorial, and then it would be 6 factorial
And 38 factorial? Okay, so then actually, it's just the reciprocal of that, right? So it's 38 factorial, 6 factorial over 44 factorial, because it was in the denominator. Okay, so you guys remember where your choose button is? Remember where it's at? No. It's in math, what? Yep, math probability. Come on, you can do it. So all of you guys have the old ones. So you have to put 1 divided by parenthesis. And you have to put your first number in. It was 44, right? So you put 44. And then go math over to probability. 3. See the end choose are?
Yeah.
So 3. And we're choosing how many? 4? Oh, 6, not 4. And your parenthesis. It shouldn't need the parenthesis, but who knows? Okay. Okay, so that is 1.416620816 times 10 to the negative 7. So that means I go left 7 times, right? So the probability of winning, you guys have to remember that number where I go back.
Whenever I put the NCR, it deletes it.
Oh, you have a newer one. You do the NCR first and then go put 44 and 6 in. Okay, so yours you would do 1 divided by math probability. Oops, I didn't hit what I wanted. Math probability 3, and then you would just fill in 44, arrow over, and hit 6.
How do we do it on the older ones?
On the older ones, you have to put 1 divided by, and then you don't have to put the parenthesis, I'm sorry. You put 44 in first, On the older ones, you have to put 1 divided by, and then you put 44, and then you go math, probability, 3, and then push in your 6.
Okay.
Did you get it to work? Okay. So, 141, right?
Who did you do that?
So, the answer is 0.123456141. Is it very probable that I'm going to win? No. But do people win?
Yeah,
Yeah.
because so many other people did it. If the more people that do it, the better chance there is there's gonna be someone that wins.
Right.
But everyone in America did it. Like 300 million people.
Well,
What would that change?
and this is the thing. There is 7,059,052 different tickets that you could make out of 6 numbers.
So if everyone in America did a different number, or a different combination.
Well, not even in America,
And not even California.
not even
Nebraska.
California.
Not Nebraska.
No, I don't. I think Nebraska's bigger than 7 million, isn't it?
No, it's
So.
1.8 million.
It's what?
Really?
1.8 million.
Really?
Uh-huh.
I thought the bigger than that.
Yeah, I thought it was bigger than that.
Hold on. Let's look at it.
I'll look it up for you.
Because Omaha and Lincoln have gotten so big.
Yeah.
Well, when Mr. Ringen told us in like 8th grade, it was 1.8 million.
How do you remember that?
964 million.
Okay, so not even 2 million.
That was in 2021.
Jeez, I was a lot closer than you were.
Okay, so you would have to take like probably all the people in Nebraska, Kansas, South Dakota, North Dakota.
Yeah, that's realistic.
Iowa.
California is 39 million.
What has 39 million?
California.
Yeah, it's like bigger.
Yeah, California is bigger than,
No,
yeah.
What state
It's bigger
has
than
7
Canada.
million people in it?
Not Wyoming. Wyoming has like 100,000 people. Or like
Did you guys
300,000
hear about what
people.
happened in California, in Los Angeles?
What?
Okay, so it would take more. Everyone in the state of Nebraska would have to buy 2 tickets. No, there's almost 2 million, so 3 tickets.
Yeah.
Okay.
3.5.
Well, you can't buy 3.5.
That's how you get 7.
Okay, so
Share one with someone else.
we could do it. I one year they had a plan. They were going to win and then go buy that many tickets, like every possible ticket, so they'd win again. And I don't think that the Arizona Pick 6 game usually gets up to $7 million. Maybe it does. But do you know how long it would take you to buy 7,059,052 tickets? Because you would have to sit there and tell the person what numbers you wanted. Because if you couldn't do random, right? Because you might have 2 tickets with the same number.
You'd have to have like everybody you know go to every area that sells.
Like you'd have to give them
Yeah.
10,000 numbers to get.
I think you would need to give them a lot more than 10,000 numbers.
Well, if it's everybody you know,
7 million.
How many people do you know, man?
I don't know. Probably not that many. Anyway, it's not a good financial plan. Anyway, so let's go back.
Useless.
Okay,
to do that.
so the probability of union of 2 events. So A and B are 2 events in a sample space. The probability of A or B occurring. A or B. Big word I keep saying, what? Or. Okay? The probability of A or B is the probability of A union B. Remember, that means and. You take the probability of, A or B. Sorry. You take the probability of A plus the probability of B minus what is in their intersection. So, we're going to use a Venn diagram. We've seen those before, right? This is A, and this is B. Why are we subtracting the union?
probability of A or B.
right? And you don't want overlapping, right? Like it's not an and, it's an or. Okay, so mutually exclusive. Mutually exclusive, what does exclusive mean? What does exclusive mean?
There's select.
Right? It means, and this, that's kind of it. It's mutually exclusive. They have nothing in common. So their Venn diagrams look like what? That. So there isn't anything overlapping, so there's nothing to subtract, is there? Now, I'm going to tell you, we tend to take care of this a lot on our own, that overlapping. Two events, A and B, from a sample space are mutually exclusive if they have no outcomes in common. So just remember that. It used to, a long, long, long time ago, be a question on a state test. And I could never get people to remember what mutually exclusive was.
Oh, I've read not in this one.
Okay.
Good thing-
They have nothing in common.
Good thing we don't have the state test.
Yes, you do. You have the ACT. Maybe you'll be on the ACT.
Ooh. That's intimidated.
Very.
Tell me when you guys are good.
Good.
Good. But you're good, but they aren't good yet.
Somebody was
Thank
good.
you for it to be good.
Be gooder.
What is your weight class player?
Yeah, I have the same football.
We're playing throw top.
I'm not gonna be there. though.
We ended up like 4 from Christmas.
Yeah, this is about one I wrote my entire day.
Okay, one card is selected from a standard deck of 52 playing cards. What is the probability that the card is either hearts or face card? Shush. What is the probability of getting a heart? So we have P of a heart or face card. Okay. Well, what's the probability of getting a heart? $13 out of 52. What is the probability of getting a face card? Okay, 12 out of 52. And what is the probability of getting a heart and a face card? So 3 out of 12, 52. So we have 13 over 52 plus 12 over 52 minus 3 over 52. So 1022 over 52. Did I add right? So 11 and 11/26. Is that right? And could I get a decimal? Yes. I'm okay with a fraction. If you're checking your work, you might have to put it into a decimal. I expect to see work on your homework. Okay? If you're using a calculator to get your final answer, that's fine, but I expect to see your setup. You good? Okay. The personnel department of a company has compiled data on the number of employees who have been with the company for various periods of time. The results are shown in the table. If an employee is chosen at random, what is the probability that the employee has 4 or fewer years of experience? So the first thing I need to do is do what?
Look at how many people have been there for 4 years.
Okay, so I have less than 4 years. That'd be 157, right? Okay, that wasn't what I was going for.
Add all of the number of employees.
Right. Y is less than 4, right? We need to add up all the employees, don't we? You add them, I'll add them. We better get the same amount, right? I don't want to add them twice. And I would assume you'd use your calculator. You guys think I'm anti-calculator, but when I do statistics, you do it all the time. I got 529. Let me know if you guys got the same.
Yeah. Yeah, that's really good.
Okay, so 157 over 529. You guys know how to reduce a fraction in your calculator?
No.
Okay, type 157 divided by 529 in your calculator. Don't hit enter. Got it in there? Now go to math and look at the very first thing you see. It says F-R-A-C. What do you think that says? Fraction. And you hit it, and then you hit enter again, and if it can be reduced, it would reduce it for you.
Can't.
It can't be reduced.
Where is that at?
Math.
Oh,
Duh.
Okay. 9 or fewer years of service. So P of less than 9 years. We're still going to have it over 529, right? What's our numerator going to be this time, though?
You have to add 89 and 157.
We have to add 157 and 89, but they are mutually exclusive, right? I can't be there both 4 years and 5 years, can I? No, so I don't have to subtract anything like I did with the cards. So I just add those, 246. And if I want to make sure it reduces or not reduces, 246 divided by 529. And it doesn't reduce. And to me, that diffraction doesn't do you much good, does it? Like in your brain? Because you're going, I don't know what that means. Did that help you a little bit more? What percentage? What's the probability in a percentage? The decimal is 0.465. What's the...
6.9%.
Right. So it's about 46.5%. So almost half of the people of the company have been there less than 9 years, right? Okay. Can you make some judgments on that? Yep. Okay. Independent event. 2 events that have no event. Wait. 2 events that have no effect on the occurrence of the other are independent events. Mutually exclusive may, but independent have nothing to do with the other one. They don't change anything. So can anybody give me a probability? Okay. Me coming to school and Bladen coming to school, does that have any effect on each other? No. No effect. Okay. And this is a probability of independent events, and I'm going to say A and B. Okay? Before was an or, and you added, yes? We added?
Yes.
This is an and guess what we do?
Subtract.
Nope. Multiply. Have we been doing that already?
Yes.
Yes, we have. Because picking numbers and stuff, that happens and. Like throwing the 2 dice. I threw throwing my first dice and throwing my second dice has no effect on each other, correct? But I have to get this number and this number. So that those aren't probabilities, but that's kind of the way to think about it. Am I good? Okay. Okay. So a random number generator on a computer selects three integers 1 through 20. What is the probability that all three numbers are less than or equal to 5? Do they have any effect on each other? No. So we're doing the probability of three numbers less than 5. Okay, well, 1 through 20, how many numbers are there?
20.
There's 20. Well, how many numbers are less than equal to 5?
20. You're 5.
5? So that's 1/4, right? But how many times are we throwing out a number? 3 times, right? So the probability, I shouldn't have put this, the probability of n being less than 5 is 1/4, but the probability of getting 3 numbers less than 5 is 1/4 and 1/4 and 1/4, so it is 1/64. So you just have to figure out the of 1 and then you keep multiplying. So yes, every problem that you have is an application problem. And you just got to read them till you understand what they're asking for. Remember, there are help with all the odds, right? If you need it. And I do give you